When upgrading or relocating electrical services, properly bonding your cable TV service and satellite dish is crucial. This ensures safety and compliance with the National Electrical Code. Let's address the question of running a 6AWG copper bond conductor from an existing ground rod to a new electrical panel, specifically when the old service location differs from the new one. In this scenario, you can run a 6AWG copper bond conductor from the old ground rod through the crawl space and up into the new panel ground log. Here are the steps to follow for a safe and effective installation. Firstly, disconnect the power. Turn off the main breaker at the new panel. Disconnect the cable TV and satellite dish from their power sources. This is a critical safety precaution. Secondly, locate the ground rod. The old ground rod should be located near the old service entrance. Thirdly, run the bond conductor. Use a 6AWG solid copper conductor. It can be bare or green insulated. Run it from the old ground rod through the crawl space and up into the new panel. Fourthly, secure the bond conductor. Use conduit cable clamps or straps to secure the bond conductor to the framing or other supports in the crawl space. This prevents damage and ensures a neat installation. Fifthly, terminate the bond conductor. Connect the other end of the bond conductor to the ground lug in the new panel. Ensure a tight and secure connection. Sixthly, bond the cable TV and satellite dish. Connect a 10AWG copper bond conductor which should be green insulated. Run it from the bond conductor in the new panel to the grounding block or bonding point on the cable TV and satellite dish. Seventhly, restore power. Once everything is connected, restore power at the new panel and reconnect the cable TV and satellite dish. Running the bond conductor through the crawl space offers several benefits. It provides a direct and low impedance path for fault currents. It avoids the need to trench to the new ground rods at the new service, which can be expensive and time-consuming. And it meets the requirements of the National Electrical Code for bonding grounding electrodes. The National Electrical Code, or NEC, provides specific guidelines for grounding and bonding to ensure electrical safety. Grounding and bonding are essential for protecting people and equipment from electrical shock and fire hazards. A grounding electrode system typically consists of ground rods, ground plates, or underground metallic water pipes that are electrically connected to the earth. The purpose of the grounding electrode system is to provide a low impedance path for fault currents to return to the source, allowing overcurrent protection devices, such as circuit breakers or fuses, to quickly interrupt the circuit and prevent dangerous voltage buildup. Bonding, on the other hand, involves connecting all non-current carrying metallic parts of an electrical system together to create an electrically conductive path. This includes metal conduits, enclosures, equipment frames, and other metallic components. Bonding ensures that all these metallic parts are at the same electrical potential, minimizing the risk of electric shock if a fault occurs. When a fault occurs, such as a short circuit, current flows through the grounding and bonding system back to the source. The low impedance path provided by the grounding electrode system allows a large fault current to flow, which quickly trips the overcurrent protection device and de-energizes the circuit. Without proper grounding and bonding, fault currents could take unintended paths through people or equipment, resulting in electric shock, fire hazards, or equipment damage. The size and type of grounding and bonding conductors are determined by the size of the electrical system and the type of equipment being grounded and bonded. The National Electrical Code provides specific tables and guidelines for selecting the appropriate conductors and connectors. It is important to follow these guidelines to ensure that the grounding and bonding system is effective and safe. Grounding and bonding requirements can vary depending on the specific application and the type of electrical system. For example, different rules may apply to residential, commercial, or industrial installations. It is important to consult the latest edition of the National Electrical Code and any applicable local codes to ensure compliance. Regular inspection and maintenance of the grounding and bonding system are essential to ensure its continued effectiveness. This includes checking for loose connections, corrosion, and damage to conductors and connectors. Any issue should be promptly addressed to maintain the integrity of the grounding and bonding system. The 2014 National Electrical Code provides comprehensive requirements for grounding and bonding of electrical systems. These requirements are designed to minimize the risk of electric shock and fire hazards and to ensure the safe operation of electrical equipment. Article 250 of the National Electrical Code covers the general requirements for grounding and bonding. It outlines the purpose of grounding and bonding, the types of grounding systems, and the methods for grounding and bonding different types of equipment. Section 250.4 specifies the general requirements for grounding and bonding electrical systems. It emphasizes the importance of creating a low impedance path for fault currents to return to the source and minimizing the potential for voltage differences between different parts of the electrical system. Section 250.24 covers the requirements for grounding separately derived systems such as generators and transformers. It specifies the methods for grounding the neutral point of these systems and for bonding the equipment grounding conductors. Section 250.30 provides requirements for grounding electrode systems. It specifies the types of grounding electrodes that are permitted, such as ground rods, ground plates, and underground metallic water pipes, and the methods for installing and connecting them. Section 250.50 covers the requirements for bonding electrical equipment. It specifies the types of equipment that must be bonded, such as metal conduits, enclosures, and equipment frames, and the methods for bonding them together. Section 250.64 provides requirements for grounding electrode conductors. It specifies the size and type of conductors that must be used to connect the grounding electrode to the electrical system. Section 250.92 covers the requirements for bonding service equipment. It specifies the methods for bonding the service enclosure, meter socket, and other service equipment together. Section 250.94 provides requirements for bonding communications systems such as telephone, cable TV, and satellite dish systems. It specifies the methods for bonding these systems to the electrical grounding system to minimize the risk of voltage differences and electrical interference. Ensure that the bond conductors are properly sized and installed according to the National Electrical Code. Inspect the grounding system regularly to ensure it is in good condition and providing the necessary protection. Proper bonding and grounding are not just about meeting code requirements, they are about safety. By following these steps and adhering to the NEC, you can ensure a safe and compliant installation for your CATV service and satellite dish. Remember, if you're not comfortable working with electricity, always consult a qualified electrician.